Hello guys, and I hope you're doing okay and everything is fine. So I just want to take you through the engineering drawing section B, at least to show you what are some of the aspects that was expected of you in your last end of term exam. So I'll start with the first question, which was the size of a triangle is given by that BC 65, CA 45 millimeters. Draw and circumscribe the triangle. So it was a question that wanted you to recall on how to circumscribe a triangle. So if you try to drag your mind a little bit, you discover that that question can come in either circumscribe, inscribe, or ascribe format. So for our case, circumscribe means you have to draw the circle outside the triangle, and you have to make sure that the circle touches the sides of the triangle, not the lines but the sides. If it's point A, B, and C, the circle has to pass through points A, B, and C. So the first step you need to know is construct the triangle, and here you're just using a pair of compass and a ruler to construct the triangle, because the question was asking you to construct. So we have to see some arcs to show that you did construct the triangle. So the first point, you have to draw a horizontal line, mark a starting point as point A, as you can see. Measure the correct distance from point A to point B. Make an arc, that is your second mark, label it as point B. Then to get point C, you have to use BC and CA to get point C, whereby BC is equal to 65 millimeters, which is the same as 6.5 centimeters. Then CA is 45 millimeters. So the two arcs will intersect at point C. That will be the third point. The final step is you join points A, B, and C to form the triangle. Now we come to the second section, which is to circumscribe the triangle. And from that aspect, you know that to circumscribe, I have to make sure that the triangle is inside a circle. So the first step that I'll have to do is I'll have to bisect any two sides of that triangle to get the midpoints, and those two midpoint lines will intersect at a point O, which is the center of that circle that you need to draw. So for my case, I picked side BC and side BA. So to bisect side BC, I stood at point B, stretched my compass to at least more than 3/4 of that line, made an arc above and below that line. I transferred the same point to point B. Using the same radius, I made an arc above and below line BC, and I joined them. That formed my first perpendicular bisector. Then I went to side BA. I also did the same. Stood at point A, stretched my compass above 3/4 of line AB, made an arc above and below. I transferred the same point to point B. I stretched my compass again, made an arc above and below line AB. So I joined my line for the two arcs, which formed my second perpendicular bisector. So I discovered that the two perpendicular bisectors are to intersect at some point, which was, I can label it as point O, which is the center. Then I used that point. If you stretch your compass to any points of the triangle, that is point A, B, or C, you can stretch it to point A, then you make the circle. So the final result was the circle. So that one was supposed to be bold. That's just how you draw a circumscribed triangle. So on to the next question. So there was this kind of question, and the question was asking, construct the following polygon on the same drawing: pentagon, hexagon, heptagon, nonagon, decagon, given the length of one side. You are given the length of one side as 50 millimeters. So if you're given this type of question, you can recall in our class we did a two-sector segment of how you can construct regular polygons, and I gave you some of the hints on how the questions can come. So under that, we always look at construction of regular polygons given the radius of a circle. That is, you have to construct a regular polygon inside a circle. And another set of questions can come as construct of regular polygons given the length of one side. So those are two different ways you need to construct those regular polygons. And I said, and I emphasized on, if you're asked any question on construct a regular polygons inside a circle, given the radius or diameter, the first marking point has to come from, you have to construct the circle. So the circle is your first marking point, because whatever the examiner is trying to test you is, you make sure that that regular polygon is inside the circle. So for this case, this question was, you have to construct a regular polygon, but you are given the length of one side. So you are not supposed to use that procedure for the length given the radius, because now this one was to test on if you know the procedure on how to construct any regular polygon given the length of one side. And I gave you this procedure because it applies on all other regular polygons. And another key point that you have to look for this type of question is construct. When you're asked to construct, we always want to see the markings, the arcs. If you see the arcs, then it means that you constructed. But if you just see the dots, it means you are measuring the measurements. So you'll be denied a mark for construction. So always, questions for construct, make sure that you just use a pair of compass to make the arcs, so that the examiner can know you did construct the question, at least what was asked. So if you look at what was supposed to be done, so this is how we did the constructions. And if you look at the marking scheme, we're saying correct constructions, 1 mark each, which is 5 marks, accuracy mark for each, which is another 5 marks also, because each construction had an accuracy mark and the correct construction. And if you see in my diagram, there is no measuring. I've used the axe. So like always, that I've always told you is the first step that you need to do is always draw a horizontal line. Mark your first starting point as point A. Then using a ruler and a pair of compass, measure the length, which is 50 millimeters. Standing at point A, mark your second point, which is point B. So if you look keenly at point B, there is an arc to show that I did construct that measurement. I did not just measure, because I gave the boundaries, the bounding limits of the question that I was asked. Then the next step is you have to construct a perpendicular bisector, that is the midpoint that cuts line A and B. So that one also takes you to the hint that you have to have as a person. And you remember in class the procedure of constructing a perpendicular bisector to a point, to any line. So you stretch your compass to at least 3/4 of that line, or you can use, because the measurements is too small, you can just use point A and B. Using the same measurements, make an arc above and below the line, standing at also point B without altering the measurements. Just standing at point B, you also make an arc above and below the lines. So there will be 2 arcs, one that is below and another that is above. Then you'll make a straight line by joining the 2 arcs. You'll have bisected line AB and gotten the midpoint. So you can label that midpoint as M. Then at point A, you can construct an angle of 45 degrees. And at point B, you have to construct an angle of 60 degrees. So whichever the case, if you start at point A, you can either construct 60, point B, 45. So I started by constructing the 45 degrees angle at point A. And I said that for you to construct an angle of 45 degrees, first you'll have to construct an angle of 90. Then you bisect the 90-degree angle to get 45 degrees. That's exactly what I did, if you can see from the diagram. So I started by constructing an angle of 90 at point A, which can be done by standing at point A. You have to stretch your compass to a reasonable, maybe radius, make an arc in both sides of the line. So starting at point A, you can make an arc in both sides. The other side, that is the left side and the right hand side of point A, to get two arcs. Standing in either of in both arcs, you can make two arcs above and below. Then you join the two arcs to get the 90-degree angle. For you to bisect, you stand at point A, make an arc that has a reasonable radius to the perpendicular bisector and the horizontal line. Then you join the two arcs to get the 45 degrees angle. So you can stretch that 45 degrees angle because it has to pass through that perpendicular bisector to the other side. Then you come to point B to construct the angle of 60 degrees by using a reasonable radius. Starting at point B, you stretch your compass to any size of your horizontal line. You make a very big arc going towards the right side. Then you also start at that arc with the same radius, make another arc to get the angle of 60 degrees. So you'll find that the 60-degree angle and the 45-degree angle will meet the perpendicular bisector at points 4 for the 45 degrees angle, and the 60-degree angle it will be at point 6. So in order to get the point 5, so that you can have a uniform distance between each of the points till point 10, then you'll have to bisect the distance between point 4 and 6 using the same procedure. Stretching your compass to above 3/4 of the line, make arcs on both sides of the perpendicular bisector and join the two. So you'll get point 5. Then you can use the distance between point 4 and 5 because it's equal to mark uniformly across the vertical line, that is the vertical perpendicular bisector. So you'll get point 4, 5, 6, 7, 8 onwards until 10. So in order to draw the first regular polygon, which was, if I go back to the question, was a pentagon. So remember that a pentagon has 5-sided. So I'll have to stand at point 5 because that is where I can draw a regular pentagon that has a 5-sided measurement. So starting at point 5, I'll stretch my compass to point A, draw a very circle that touches point A and B. So if I draw that circle, I'll measure the distance between A and B, which is 50 millimeters, and mark uniformly throughout the circle. And if you do it accurately, you'll discover that the last mark will form the last point of that regular pentagon. And if you want just to know if you're accurate, always the regular pentagon, the 5-sided figure, it will coincide with the perpendicular bisector. There's a point that will be directly in contact with the perpendicular bisector. So if you discover that it's just that way, then your diagram is very accurate. Then you will also do the same to the next question, was saying hexagon, heptagon, nonagon, decagon. Hexagon is a 6-sided figure, heptagon 7, nonagon 9, decagon 10. So you'll also do that all through for the other regular pentagons, and you get a resultant feature like that. So that's how you can do for construction of regular pentagons given the length of one side. Always remember this procedure because it cuts across all the others. But if it's construction of regular pentagons given the radius or diameter, then it means that is you have to look at how to construct a regular pentagon given the diameter and the radius inside a circle. So that is the question again. So we go to the next. So the next was construct a regular pentagon in a circle of diameter 60 millimeters. So this is another set of questions that I was telling you. So here we have been given the diameter. So it means that the first step that we have to do, the first marking point, is we have to draw the circle. So that is If you look at the marking scheme, it was correct, circle, diameter, 1 mark, accuracy, labeling, neatness, and the construction. Because the question is telling you to construct. So you are expecting that we have to see some arcs, meaning that you did some constructions. So the first step, you have to construct the circle. By drawing the circle, you can draw a horizontal line, mark your starting point, and I've always emphasized on that because it shows the procedure moving from one step to another. At least you can know where you started from and where you're going. And if you get confused in along the way, you can be able to pinpoint where you went wrong and come to rectify on it. But if you do not label it, then it can be very difficult on your end to know exactly where you started or where you are going. So you can be confused. So I'm always emphasizing you on always label your diagram so that at least it will help you to know the concept. If you are doing it and labeling it more frequently, you'll be able to get the procedure. So the first step, you have to to draw the circle with the radius O. Of course, you've seen for me, I've drawn a regular circle with the radius O. Bisect the circle into 4 equal parts or 4 equal quadrants. After that, you can bisect either one side of the quadrant or one side of the radius. So for me, I used point OB. I bisected it to get a midpoint M. And then I transferred. Starting at point S, and I draw an arc that can pass through point AO, and I transferred the same point towards the circumference of the circle to get point T. So after you do that, then it means that ST is your first radius, not radius, but the first length of the regular pentagon. So I'll have to mark uniformly around the circle. I'll get that I'll have to mark 5 times, which forms the 5 points or the 5 sides of the pentagon that are equal. So that will be my resultant figure. So that was the correct procedure, and if you can look keenly at the diagram, you can see some arcs, meaning at least you did some construction. And then next we have draw the power circuit diagram of a direct online starter for a 3-phase motor. I know we did not do it on engineering drawing, but at least in principles, electrical principles, we did some 3-phase and single-phase motor starting methods, and I gave you some of the circuit diagrams about the same. So I really wanted to know if you can really recall how a direct online motor starting method, which is one of the methods under the 3-phase motor starting methods. And I told you from the electrical principle side that in order to avoid that starting torque, high starting torque, in order to balance the load that is enabling the motor to rotate so that you can have a smooth rotation that has an equal starting torque, then we have to employ a 3-phase motor starting method. So it eliminates that high starting torque, which can give a high starting current and voltage. So if you look at how my drawing has been drawn, I started first by the 3-phase. You have to draw the 3-phase, the red phase, the yellow phase, and the blue phase. Or another person can use line 1, line 2, and line 3. So whichever the way. And then you draw another vertical line. It will first pass through the QR, the circuit breaker. Then you have a fuse. Then you have a main contactor that is normally open. Then you have an overload relay that protects the motor from excessive currents and voltages. So that you can prevent that high starting torque. In case the voltage or current is slightly higher, then the overload relay will open. It will become normally open. So it protects the load, that is the motor. And it also ensures that there is that stable rotation that is swift and smooth. So that is just how you can draw. This is just a very simple power circuit of powering the motor using the direct online method. Then we have the next question, which was construct a common internal tangent to 2 circles of equal circles diameters 55 millimeters with their centers spaced 75 millimeters apart. So this question also turns you back to the time we were doing construction of regular tangents inside a circle and outside the circle. It's under the subtopic circle and tangents. So you have to know that the first marking point has to come from, you will first draw a horizontal line, then mark your starting point A, measure a distance of 75 millimeters from point A, because we are being told that the centers are spaced 75 millimeters apart. So you have to start at point A, measure 75 millimeters across that horizontal line to find point B. And then at point A, you will draw the first circle that has a radius of 5, a diameter of 55 millimeters. And at point B, you'll also construct or draw a circle that has the diameter 55 millimeters, because the two circles are of equal diameters. Then after doing that, you will construct a midpoint by dropping a perpendicular bisector that cuts through AB. So the same procedure also applies for construction of midpoints by starting at point A, stretching your compass above 3/4 of that line, making an arc above and below. Starting at point B, stretch your compass again using the same radius that you did for the first step. Make an arc that is above and below, join. So it will form the first midpoint. To get the midpoint, the second midpoint and the third midpoint, if you can look at my diagram, I've labeled M, M0, M1, M2. So to get the point M1, which is in between the main midpoint and point B, I'll also do the same, construct by dropping a perpendicular bisector between the 2 points M and B. I stretch my compass to 3/4 of that line, make 2 arcs, one above and below, then stand at point B without tempering the radius of that point. I make above and below and I join. It forms a midpoint M1. At the same time, I do that on the other side, that is between points A and point M, to get the midpoint M2. After that, the next step will be starting at point M1, which is the point that is in between A and the midpoint. I'll draw a semicircle that is going upwards. So the semicircle will touch point A, and the second point will be at point M. Then to get another semicircle, I will start at point M1, which is our second midpoint, the second minor midpoint, because it's in between M and B. I draw an arc that goes downwards. That arc will run from point M to point B. So you'll find that that arc will cut the circle at some point. So that's where I'll join those 2 points to form our internal tangent. So that's the same case on how you can construct that. Then we go to the next point, or the next question was, construct a rhombus given the length of one side as 90 millimeters and an angle of 60 degrees. So that also brings you to the same aspect, construct. And you always have to remember this when you're doing that. Any questions given, construct. I'm expected to make some arcs so that it can really show I did construct, I did some constructions. So the first time we are looking at a rhombus. A rhombus, we said, is a twisted square. It has all the 4 sides are equal. So the first step you'll have to, if you look at the marking scheme, it says correct 60-degree angle construction. There's a mark for that. There's a mark for neatness. There's a mark for labeling. There's a mark for accuracy. There's a mark for correct measurements. So always follow that procedure. Don't assume. You might end up doing the constructions you have not labeled. You'll be denied 1 mark for labeling. But you did do the correct constructions. So at least I want us to eliminate even the slightest possible mistake that you can have to make that can deny your mark, because you want those marks, you want to acquire them. For the first step, you have to draw a horizontal line. Mark your starting point as point A using your ruler and a pair of compass. Measure 90 millimeters. Then starting at point A, make an arc at point B. So the points A and B are spaced 90 millimeters apart. Then you have to use the procedure for constructing a 60-degree angle by starting at point A. You can switch your compass to a reasonable radius. You can use a radius maybe a length of maybe 1 centimeter, that is around 10 millimeters. Make an arc from the horizontal line going towards the left side. Start at that point where you made the arc. That is the second point. And then you have to make an arc so that it can cut the first arc. Then you have to join. So it will be a 60 degrees angle. Then the same case, you can also do it on the side point B. Then since it's a rhombus, you can use 90 millimeters, measure 90 millimeters on your ruler and a pair of compass. On your line, on the first line that you drew at point A, the 60 degrees, you can measure the 90 millimeters, and your second line also measure the 90 millimeters. Where they will meet, join the 2 points to form ABCD as your resultant regular polygon or regular shape, that is a rhombus. So that's how you can draw for that. Then you go to the last question for section B, which was draw the views of the following block in first angle projection and make 5 dimensions to the views. So this was the view, and you are given the front. You consider that which was on your left side as a front elevation. So if you're given these questions, you have some very key points that you have to consider. So you have to look at 5 major dimensions. So for you to get the 5 marks, there is 5 marks, 1 mark each for a person who did dimension the sides of those views and given at least 5 of them. So and again, you look at, after you have made the views and you have drawn, how can I insert 5 major dimensions? By using the rules of dimensioning that we learned in class. On when dimensioning an object, you should not over dimension it. You should not, at least the dimension should not just sign, it should be spaced. It should be spaced in the diagrams or in the views. So that turns to orthographic projections, because this one is an isometric block. It has the length, the width, and the height. But drawing the views will be in 2 dimensions, showing the length and the width. So the first question, if you're given these types of questions of isometric, first angle, third angle, I told you is first, before you even start the question, always sketch the views. Sketch the views on how you can see it from your front elevation, how you can see it from your end elevation, and how you can see it from your top or the plan. And if you consider the front elevation, what you can be able to see is, you'll see that L face that looks like an L. Then we have that hind face that looks like a triangle. So those are the 2 faces that you'll be able to see. If you look at from the end elevation, and I said if the question has told you to consider the front elevation as that, then on your right hand is always the end elevation, if you have not been given. But if they can twist a bit and consider the right hand side as the front elevation, then you'll know that your end elevation, it will be on your left hand side. So depending on how the examiner will have set the question, that is how you'll put it. So don't assume that always just like that. But if it's not labeled, always consider your left hand side as your front, your right hand side as your end, and then the above as the plan. So if you come to my end, I did some sketches. I sketched the plan, whereby I drew the front, I drew the L face and the hind face. It was coming like forming something like that. Then the end elevation, I also did it, and then the plan. After I've drawn all that, I now have to recall. Now it's a matter of recalling. When we are doing first angle projections, what are some of the major points to note? Like I said, in first angle, the plan is always below the front elevation. That is a very key point that you need to know. So after you know that, depending on whichever place you'll put the views, but always remember that the plan will always be below the front elevation. After you've sketched the views, you have put the dimension and everything, you have noted down that. Now I'll come to the real drawing. So if you look at my drawing, this is how I drew. So the front elevation is there, the plan at the end, and I used the 45 degrees angle to make the projections, to project or to stretch, such that I cannot be able to just do one diagram at a time. So I always say that when drawing, you have to draw vertical and horizontal lines. You are drawing the x and y axis, so the real x and y axis, and then you have to be spaced 10 millimeters from the main axis to get the axis where you'll be required to draw the drawings. And then the other thing that you have to know is find the maximum height, find the maximum length, maximum width, the maximum height. So if I can just turn it to the same diagram, if you look at this diagram, the maximum length from the front elevation is 60. The maximum width is also 60. The maximum height is 40 plus 20 is 60. It's like a cube of 60 by 60 by 60. So that's the same case that you have when you come in to draw them on the planes. You look at the maximum height is 60 by 60. And you also have to make sure that all those views are in proportionality. There is no one that is overlapping the other. And you look at my dimensioning. I did dimension 5 major dimensions in any of the views, so that it at least, as I followed that rules for dimensioning. So that's the same way that you can do on your end, and it always have to make sure that at least you give something that is okay, because most of you are getting 15 because they did not do the final part, which was dimension the object. So if you are told, those are some of the questions that come in that way. If you're told to insert 5 major dimensions, always remember that 5 marks are from dimensioning that object. And I'll do another tutorial on how I can show you how you have to dimension. Each object is dimensioned at least. So otherwise, I hope this video helps you also how to revise. It also puts you in a place where you can assist you. It can assist you when doing some other revisions on your case or on your end. Otherwise, have some great time.